I think Google, at last count, has 9 business units with over 1 billion users each. Maybe it's 10. I think it's at least 9. Is that correct?
Yeah. So the number I was told when I started was we had 7 services that took over 1 billion users a day between YouTube and Gmail and several others that a couple I didn't even know existed. But yeah, so we do scale like nobody else on the planet, and that's a big part of that's built into our DNA.
Yes. And when did you start with Google? When it was only 7 billion?
Well, it may well be 9. I'm actually relatively new to Google. Just actually a few months in at this point.
Got it.
But I've been working with Kubernetes since it was written in Python.
Wow, so a lot of great insights. I remember, wonder if there's YouTube and Gmail and Google Search, and then there's Google Pictures, and there's Android, and I'm sure I'm missing a few more. But if people want to know, I'm pretty sure the number's 9. But the relevant topic is that's why Google is going to be such a relevant player in the enterprise cloud space for many years to come, is because they have all this incredible computing power and all this incredible user base, and that gives them the capabilities, the insights in trying to deploy that expertise they gain from supporting God knows how many YouTube live streamings every nanosecond. That insight and that expertise is then repackaged into services offered through the Google Cloud Platform. One of the recent announcements, well, probably not so recent, I think Google announced Anthos a year ago, give or take a little bit.
It's just over a year old for general availability, yeah.
So it's really interesting. This is their major initiative to support hybrid cloud and multi-cloud environments, which are so relevant. And so without any further ado, I think it's going to be very insightful. Let's now turn it over to Jamie to hear the GCP strategy.
Yeah, thanks a lot, Ron. And again, we're going to be talking about Anthos today. Anthos is sort of Google Uber brand for where we think computing is going. So it's very much built around Kubernetes, and it's very much built around this sort of hybrid multi-cloud scenario, because you have to be. But I try to lean away from saying hybrid cloud or multi-cloud as much as possible, because I think if we push that way, then we lay the bias onto our customers that they have to be in more than one cloud. And while that's probably a good business decision a lot of the time, it's not one that we want to be a primary driver. We want you to operate efficiently wherever you are. And that's the tagline for this slide deck today. A little bit about me, because I am relatively new to Google. Name is Jamie Duncan. Was at Red Hat for a long time. Worked on OpenShift, which is the Red Hat Kubernetes distribution from early on, prior to Kubernetes being the main tooling of it. Went over to VMware to help work on the Tanzu project, which is their Kubernetes distribution. And am now actually at Google working on Anthos, which is sort of our Kubernetes-centric, container-based, multi-cloud, all of those buzzwords, platforms that we think is going to be the way computing is going for the next 5 to 10 years. I'm a big F1 racing fan, where we got the season started finally, I guess about 6 races ago. And in my spare time, I like to take old tools and fix them up. So old turn-of-the-century vices and wrenches and that kind of fun thing. Just an odd little hobby that I actually found on YouTube. I'm one of those billions of users. All right, so I put together a little bit of an agenda today. Anthos is an odd word, so we're going to define what Anthos is a little more clearly. Again, taking that idea that you will probably end up with multiple platforms at some point, whether it be that you're in multiple cloud providers or you're in multiple variations of an on-prem infrastructure, and all of the combinations and permutations. The real secret to success, or one of the key secrets to success, is that you have consistent workflows across all of them, and that's what Anthos strives to provide. And then I try to pick some of the more transformative components out of the Anthos stack. This is not the totality of what Anthos does, but I try to pick some of the more interesting, more transformative toolings, looking at the various personas, looking at the people that are going to be writing the applications, looking at the people that are going to be building the actual infrastructure, and then looking at the people that are going to be doing the SRE type roles, and operating the infrastructure after it's deployed. And then hopefully we'll have a few minutes for conclusions and Q&A. The good part of this agenda is
share your PowerPoint slide.
Pardon? Somebody just
Well,
popped in there for a second.
Yeah, I'm not sure. Okay. It
Okay.
might have been
No worries.
a,
I didn't know if they were asking a question or what.
I think we had one of our previous presenters.
Oh, someone we forgot to mute. No worries.
Yeah.
All right,
No.
so lesson for me to make sure I mute afterwards. The upside is that this, I think, is some pretty interesting content. The downside is that there are a lot of slides. So if you haven't already noticed, I'm going to be talking on podcast speed and to try to get to the end of the content. Not my usual MO. I like to have more like 10 or 12 slides and let us dissect and chew on them for a while. But to get to this, to get these concepts teased out, we're going to be hitting the click button a whole lot. So apologies for that. We will have these slides available afterwards. And at the front and the back is my Twitter handle, which is a really easy way to get a hold of me if you have any questions for follow-up or questions during the Q&A here. All right, so let's define Anthos real quick. Anthos, like I said, is Kubernetes is the beating heart of Anthos, but we have to have a little bit of a history lesson first, because that idea of, it is a noun. There's Google scale, that you scale up to literally billions of users, that you scale to a truly global network, not borrowing anyone else's fiber, not borrowing the public internet to get around. Google has literally a global network. And we've been working on this a long time. And we've built, I don't know how many millions of engineering hours we've expended to be able to do this well. Going back from 2003, when we did the first sort of automation of cluster management with Borg, and the Borg all the lessons learned in Borg evolved into Kubernetes. Going all the way from back then and even earlier, we've learned a lot of lessons, and we have a lot of scar tissue, and we've figured out what we think is a pretty good way to deploy applications at scale. And maybe Google scale, maybe not Google scale, but whether it's hundreds or thousands or millions or billions, deploying applications at scale reliably with good observability, with a good experience for the developers and the operators and everyone in between, and in particular the end users, we've spent millions of hours figuring this out. And those millions of hours culminate in what we are calling Anthos. And I say that like it's a big thing because it's kind of a big thing. That all of the Google engineering hours for all the different things we've done, all of that is being distilled into this Anthos offering. So I think that's pretty cool. That's really what got me here. So a little bit of a history lesson. I don't want to get too far into it. Again, we have a lot of content to cover. Anthos is available pretty much anywhere. So obviously the best experience, at least in my opinion, is running Anthos on Google Clouds, on our cloud. The primary reason for that is that the Kubernetes componentry, we tend to abstract away a lot of the Kubernetes control plane, and you don't have to deal with it as an end user, as a consumer of it. We let our SRE team tackle all of that and make sure that it's up and available for you. And if you've ever dealt with Kubernetes before, you know that that is a big part of the care and feeding of any one cluster, much less hundreds or thousands, is keeping the control plane happy and healthy. And on GCP for Anthos, we do that for you. Obviously, since we can't ship our SRE teams into your data center or into Amazon's or Azure's or anyone else's data centers, the on-prem and other solutions look a little different just because of out of necessity, but they do the same thing. The workflows that are exposed to developers, the workflows that are exposed to the operators are the same as the ones that are exposed in Google Cloud. And it focuses, and I was listening to the tail end of the Trend Micro talk. It's very much around policy management and service management and cluster management, which is another way of talking about his sort of OSI model around security. Making sure that we have all of the right RBAC in place, making sure that we have the right controls in place across the cluster and across all of the cluster services to do that work for you. So Anthos deploys anywhere, from edge computing use cases like in the retail industry or business continuity, all the way, in our cloud primarily, and then also on-prem and in other cloud providers, AWS and Azure as well. So we can put Anthos anywhere. Bare metal is still being worked on and sort of the DIY. That's still being worked on. That hasn't reached GA yet. And you can also take other Kubernetes clusters that are not, Kubernetes deployed by Google tooling, and register them into Anthos, called an Anthos attached cluster. So you can actually take OpenShift and attach it to Anthos. You can take, I attached yesterday a Raspberry Pi cluster from my own closet and attached it to Anthos inside GCP. All of that's pretty cool. It's pretty cool stuff. And that gives me all of the policy management as one single coherent thought. And that one workflow becomes really important. What lets Anthos be the same everywhere is that it's all 100% software based. And I'm not going to linger on this slide a lot. Again, you can take a look at this in a little more, at this eye chart a little more if you want to later. But every component inside Anthos is built on software. We are not dependent on any single hardware configuration to get the job done. Outside of basic routability, we're good. All right. So let's hammer in that idea of having a single workflow for all of your workloads. And what that means is being consistent is difficult. And talking to customers about Kubernetes, as I've been doing for the past 5+ years, as they start building out these one-off projects, and as customers start going into multiple clouds, they have their on-prem data center running primarily VMware, and then they've got Amazon running all of the Amazon-centric workloads, or they're in GCP, or they're in Azure, or wherever they happen to be. The nightmare scenario is that they've stretched one application services across multiple clouds, and something goes wrong. And it's hard enough to go through all of those services, and if you don't have great observability, and figure out what's broken where. But if the applications on your on-prem stack are deployed and managed and feel completely different than the applications deployed in your cloud provider's application stack, it's just a recipe for pain, and lots of pain when things go sideways, and things invariably go sideways at some point. Excuse me. So being consistent is important. And it's also very hard, because we've got a lot of inertia, and we have a lot of people coming in your door talking about that their tooling is the best way to do the tooling to solve all the problems. And you're just sort of assaulted with the best way to do it. Everyone's opinion is that their opinion is the best opinion. And it's hard to it's hard to do that. So Anthos, we think Anthos is a little unique because we've proven that Google walks the walk. We have, like Ron said, 9 products that have over 1 billion users every day. We know how to scale, and we know how to stay up for customers. And all other things to the side, we can say that and demonstrate it with facts and reason. We think Anthos is the best way to get there, to be consistent across multiple platforms. And cluster sprawl. How do you handle that? So the solution, and I really, really hate saying single pane of glass, but I'm going to say single pane of glass, is to have one place to control all of your environments, to control that policy, to control who can access things, and how can one application communicate with another application, and have monitoring and metrics and observability for your entire fleet of clusters, no matter where they are and what type they are, whether you deployed them on a VMware VM, whether you deployed them in GCP, whether it's a Rancher implementation that you're running out in the edge for all of your edge locations. Being able to funnel all of that information up into one place, and that knowing that place has all of the knowledge and experience that Google provides, that's what Anthos is all about. It's pretty cool, and it's pretty awesome technology. And it's hard for me to try to sound partial about it, because it does a really good job. All right, multi-cloud edge orchestration services. Again, we're 100% software based, so we don't rely on any sort of hardware specifications outside of just the number of CPUs and the amount of RAM, and the amount of storage. And it's built on open software. We're not doing this behind closed doors. We're doing this out on GitHub. Kubernetes is open sourced. Istio, that we're going to talk about in a few minutes, is open sourced. The OPA gateway that is actually is open sourced, which is doing a lot of the policy enforcement inside Anthos. The tooling, obviously, the container runtimes that we use are open source, Containerd or Docker. It's all built on top of open source software, and that makes sure that if you're using Anthos this year and next year you decide not to use Anthos, you don't have to rebuild all of your workflows. A container image is still a container image. A CI/CD workflow might point to a different API, but it's still going to generate the same artifacts, and the same tests are going to run. And that's what we talk about when we talk about avoiding lock-in. Obviously, Anthos has workflows in it, and you can lock yourself into those workflows. No one's saying that's not the case. But the tooling, the objects that you create, and the way you interact with them are all built on top of open standards on open source software. And that's really important when you're figuring out how to do things, how to design for change, and how to design for more than one platform. And again, talking a little bit, kind of focusing on when I was talking about it on when you deploy on GCP, how we abstract away the entire Kubernetes control plane. Our goal with Anthos is to abstract away the infrastructure. Yes, there are people that need to understand how the infrastructure works. They still have access to it, and they're still going to take care of it. The people that have to know that have VMware experience, the people have AWS experience, the people that have GCP experience. But we want the operators focusing on observability, and we want the developers focusing on building applications and delivering value to their customers. We don't want the developers to have to make changes depending on where the application is being deployed. The code shouldn't have to understand where it's going. That's the infrastructure's job. So with Anthos, we do our very best to abstract that away as much as is possible in modern computing. The personas are important. And I didn't catch the gentleman from Trend Micro's name, but Trend Micro was talking about DevOps or DevSecOps and all those things. Different people in IT, different personas in IT look at platforms differently. And I say that like telling people out here that water's wet, but we don't think about it nearly as much as we should. Your ops team is going to look at Kubernetes in a completely different way than your developers are. Their experiences are going to be completely different. And one of the things we've learned that internally at Google over the years, and we're trying to surface that in Anthos, and we're trying to be very explicit in the way we surface that with Anthos. So we try to provide experiences that are solid for all of the personas that matter. So the security persona, the infrastructure operators, SRE personas, the developers, that sort of DevOps persona, even the business owners have access to visibility and control panels and dashboards inside GCP to give them what they need without making them have to go learn a whole bunch of extra stuff. We want you to know what you need to know and get your job done, and not have, we don't want admins to have to be bad developers and developers have to be bad admins. And we work really hard to make that reality inside Anthos. I've mentioned that lots of stuff comes back. One of the things about Anthos is that idea of a disconnected cluster is a little hard to get there. We can do it if we need to do it, but it's not our favorite thing on the planet, because we want people that are consuming Anthos to be able to use all of that knowledge inside Google and leverage it. Excuse me, allergies are blowing up today. So there is an agent when you attach a cluster to Anthos, or when you deploy a cluster through Anthos and end up with a new Kubernetes cluster, there is an agent that gets deployed. And this is pretty standard stuff. Anything that does multi-cluster federation, so OpenShift's new multi-cluster operations tooling, it deploys an agent. Tanzu Mission Control deploys an agent. Ours is called GKE Connect, and it does phone home into Google. That is completely encrypted. It is massively encrypted. We take it very seriously, but it does phone home to give you that single pane of glass, because it would have to. If it wasn't getting that information, it wouldn't be able to give you the information in a coherent, cohesive way. All right, where are we doing on time? We actually are really good on time. All right, I can turn off podcast speed a little bit. So GitOps with Anthos Config Management. GitOps is a really cool idea, and there are 100 definitions of that term, and I know it's seriously overloaded in today's industry because every term gets seriously overloaded in today's industry. But at its heart, the way I interpret GitOps is that you're taking your infrastructure, you're taking the operationalization of your infrastructure, and you're building it out, you're creating it in such a way that you can literally keep it version controlled in a Git repository. You're doing operations through Git. And that everyone says, well, I keep all of my scripts in Git, and it's not quite the same. GitOps is leveraging that CI/CD workflow concept of when I do a Git push, a thing happens. I'm running tests and I'm running test deployments, and I'm creating things and confirming that it's doing what I want it to do, and then I'm tearing those things back down if I don't need them anymore. That idea of CD concepts and CD workflows as part of your infrastructure and operations tooling, it's hard to get there because the industry hasn't gotten there. I mean, we've been working on that for forever. And GitOps really makes it realistic. So the way we've realized that inside Anthos is with Anthos Config Management. You may also hear this referred to as config sync in other places in GCP, depending on the tool that you're using. And what it ends up being is that you can define, it's a Git repository at the end of the day, at its most basic, that has a prescriptive format. So there's a directory structure and there's naming conventions. And you define your infrastructure in a Git repository. And you define the changes to your infrastructure within that Git repository. And you define security policies, and you define all of the things that you need to operationalize the infrastructure, whether it be in wherever you're deploying Anthos, whether it's in GCP or on a VMware or in AWS. You're defining a consistent policy for it, and you're defining it using GitOps principles. So when you do a Git push into your ACM repository, all of the clusters that you've told it, you've saved that repository affects, they all get the changes. And the ACM brain understands if it's on Amazon to do X, Y, and Z, and if it's on GCP to do alpha, beta, and gamma. We're trying to bring that consistency as far down the stack as we can, and even start to bring that consistency into the operations teams. It's pretty slick, and it works really well. It is one of the better, if not the best, interpretation of GitOps that I've seen. I'm a big fan of it and actually use it for development clusters every day when I'm just testing new things out. Platform service security operators, manage infrastructure, manage your life cycle. It's pretty awesome. And I don't want to spend a ton of time here because we have some other cool stuff coming up. But again, that idea of GitOps is not going to go away because it's a really good idea. And Anthos Config Management gives you a really effective way to implement that across all of your application platforms, no matter where you deploy them. So that's the overarching point that I want to make with these couple of slides. Config as code, again, not belaboring all of this. So out of one Git repository comes your entire deployment. For your team, again, just sort of reinforcing how all of this stuff works. And I do want to bring this in. This ties into the whole GitOps idea. As we were hearing about in the previous presentation, security is hard. And security across multiple clouds is even harder. And security across these microservice abstracted workflows, the stuff that we're getting into in modern IT that is making all of our platforms better, gets really challenging to be able to do this at scale. I'm not just controlling firewall rules between two servers anymore. Now I need to be able to ensure that each individual request from one API to another API is encrypted properly, and that those keys are rotated frequently, so that if one does get, if something does happen, if I am breached somehow, if I am corrupted somehow, that I'm going to minimize that blast radius. That the amount of damage a bad actor can do is the smallest possible footprint. And in addition to that, since these things, since containers can come up and go away in milliseconds, the idea of services the idea of quotas around my services become much more important. And the idea of what is one service allowed to do with respect to the other services that get deployed. I don't want everything to be able to talk to my database. So I need to write policies to do that, because I want to be able to decouple those policies from the source code itself. So centralized policy management is how all of this fun stuff happens. And all of this is part and parcel with Anthos Config Management. And for this particular part of it, we're using something called Open Policy Agent, which is increasingly the standard around this sort of centralized policy, especially in the Kubernetes community, but it's nowhere near limited to just Kubernetes. It's a general purpose policy engine. OPA or OPA, Open Policy Agent, and we're using a tool called OPA Gatekeeper, which is just the latest release of how the Open Policy Agent team thinks all of this should work. So all of that gets integrated into everything that we do with Anthos to make sure that the policies are deterministic, the policies are where they need to be, when they need to be, to make sure that the right thing is happening. It's incredibly powerful, and it does take a little bit of learning, and it does take a little bit of onboarding and on-ramping if it's not something that you've done in the past. If you've been creating firewall rules and setting IP tables by hand, it does take a little bit of a leap of faith, but the power inside that idea, the idea of centralized policy management, gets really, it's really turning your security posture up to 11. This is how and I know everyone on here has heard of zero trust, because it's a buzzword that we throw around all over the place. But if you want to truly realize and get to zero trust, this is the tool that you use to do it. This is our best attempt at it so far in our industry. Is OPA Gatekeeper, and it's open source, and we're leveraging it inside Anthos. And this is what it looks like. Again, I'm a lot of slides in and hadn't shown, a terminal. So I needed to have a terminal screenshot in here. So I wanted to get one in for this. This is what it looks like at its most basic. It's YAML, because the world is written in YAML these days. And it's a prescriptive repository. It's a prescriptive directory structure inside a Git repo. And inside there, I have ways to name the files and call the objects to create all of my stuff, to create all of my security posture, to create all of my clusters, to put them in the right place with the right permissions to get their job done, and do it over time and do it at scale that I need to get to fulfill mission for my customers. All of this is designed to build into CD pipelines, because that's where GitOps is. We're designing all of this to work with the most modern, the most effective type of workflows that we can. So Anthos Service Management. This is probably the most complex idea that we're going to talk about today, because we're talking about service meshes. Service meshes, and a lot of people call them service messes, is that sort of left-handed joke. We're talking about Istio, we're talking about Linkerd, we're talking about some of the newer stuff like Open Service Mesh from Microsoft. Anthos leverages Istio. Anthos, Google is one of the founders of the Istio technology, using Envoy proxy and all of that stuff. We're using Istio inside Anthos. And it's pretty straightforward to say, all right, we're using a service mesh, and when you need a service mesh, we're using Istio and Anthos by default. That's not saying you couldn't go deploy Linkerd inside Anthos and make it work and do all of its job just fine. But when you start looking at the out-of-the-box integrations with ASM, with Istio, that we have in our logging and monitoring and observability platforms, that we have just with inside GKE, it becomes a pretty compelling idea to use ASM on top of your Kubernetes on top of your Kubernetes deployments. So why do you need a service mesh? And I'm not a giant fan of this slide, but I can't think of a better way to, there we go. I can't think of a better way to explain it. Service meshes are for when you need fine-grained control, for when you need intelligent routing. The idea of service discovery, and the idea of service discovery without having to set DNS records for everything. The idea of circuit breaking, that the idea of load shedding, so that load shedding becomes really important when you have these unplanned scaling events. So if you're using an application, if you have a website and your website goes viral on Twitter and you go from 2,000 visitors an hour to 2 million visitors an hour, you may not have enough VMs spun up to handle the load. So you don't want them, you want to provide, when you're in that situation, you want to provide the best thing you can while you scale up your infrastructure, or while your infrastructure automatically scales up. You're going to provide the best experience possible for your end users. And if you can't give them what they want, then you need to give them something clean. So a cached version of the content, or a polite error page saying that you're working on it. That idea of shedding load from one service to another service in times of stress. You need a service mesh to do that. One of the things I mentioned earlier, the idea of making sure that every API call internally, that sort of east-west traffic, making sure that all of those API calls are encrypted, so that if someone does get inside your infrastructure and is listening, that they're not able to get things like passwords and usernames and addresses and PII, or sensitive information, out of the API request itself. It's called mutual TLS, or MTLS. If you need MTLS inside a Kubernetes cluster, you're pretty much guaranteed to be using a control plane to get there. So encrypting traceability, when you have, when your web front end is 500 containers and it's going to 4 different types of middleware that are 200 or 250 containers each, and then going into some combination of backend databases that are stretched in Kubernetes and in external services, and 1 out of every 500 requests is going sideways, is not doing what it's supposed to. That idea of tracing a single web request through that maze of services and microservices and software-defined networks and all of the things that we do these days. To do that effectively, you're looking at a service mesh. So service meshes, while they were, when the first ideas of them were sort of looking for a solution, looking for a problem, service meshes have evolved, and in particular, the use cases around them have evolved, that we should be using them these days. They're solid tools and they provide a lot of value, especially to end users. If only just the idea of a canary deployment, where if I deploy a new version of my application and I want to send 10% of the traffic there for 30 minutes, that's a lot of work to do manually. That's a really easy thing to do inside Istio. And again, I'm configuring all of this stuff. It's all YAML. I'm mapping all of this into a repository, and it becomes part of my operational experience. It's a really effective tool. So the service mesh is a transparent, language independent way to automate all of the stuff around your network. So the idea of finding services, splitting services, getting traceability and observability telemetry out of your services, that's what service meshes do. Istio is the industry leader, and I just did some research on this for a podcast, where Istio does have the most features, and it is the most mature, and it has the most sort of industry backing, including Google. That's an open platform, open source stuff. It's all out on GitHub, and it will also work with VMs. So if not everything in your infrastructure is containerized, you can still stretch a service mesh across virtual machines as well. You're not limited to just Kubernetes, although that's the use case we talk about the most with service meshes. And then what Anthos Service Mesh is we take Anthos, we then opinionate the deployment of it to function most effectively inside an Anthos environment. And that's the way most open source works these days. How do service meshes help? Again, you get observability consistently no matter where the application lives, no matter what it's doing. The ability to manage the flow of your traffic with extremely fine-grained control and extremely quickly. So you can route traffic from one deployment to another deployment. You can route traffic from one data center to another if you need to. Excuse me. And it also gives you the opportunity to integrate much more cleanly with stuff like OPA Gatekeeper, with policy-driven security tooling, with zero trust. All of it comes out of, service meshes become integral when you're talking about zero trust or least privilege. Again, this is just sort of explaining uniform observability a little bit, where application A, application B, all of their information, because the traffic is all routed through the service mesh, we don't have to put that observability code inside the source code for the application itself. That, and I'm sure you've heard that a lot of people have heard that term sidecar. The Istio sidecar that gets deployed as part of your application deployment does all of that for you. Gets all of your metrics and logs and telemetry, tracks error budgets, looks for things and reports that back up into, in Anthos's case, into our monitoring solution, into Google Cloud Ops. Operational agility, again, that's that idea of a canary deployment, traffic splitting, traffic steering, being able to circuit break, just sort of flip the switch if something goes wrong. And, fault injection. When you're doing testing, and a solid part of any modern application is breaking stuff and making sure that it's doing what it's supposed to do, and doing that in your dev and test environments, but also doing that in production as needed. So the ability to introduce latency into a request without having to go, switch port configurations in a switch. You can do that with a service mesh like Istio. I can say that, services between, communications between services A and B, add an additional 100 milliseconds of latency, and let's make sure that everything stays okay. Let's make sure that we're not overloading some message queue somewhere, or maybe we need to put a message queue in place. So fault injection becomes really a really powerful tool when you're building things to scale. It's an SRE tool that, it's used all the time to make sure that tooling does what it's supposed to do, especially under less than ideal conditions. Policy-driven security, again, making sure encryption north-south and east-west happens, using that least privilege model, role-based access controls, making sure that the proper information is coming out for auditing tooling, coming in and out of the requests, making sure that traceability is consistent across all applications, regardless of what they are or who wrote them, whether it's an off-the-shelf component or whether it's something that you've built in-house. Service meshes make all of that significantly easier. And I think this is the last one that we're going to talk about for a few minutes. And apologies for, death by PowerPoint. But again, I wanted to make sure that these are some really powerful concepts, and these are some really useful tools. So the first one sort of, we've looked at sort of the operations persona, we've looked at the SRE persona. Now we're going to look at the developer persona just a little bit with serverless, with Cloud Run. Cloud Run is Google's serverless implementation built on top of Knative. So developers use Knative, use Cloud Run to build and deploy and scale serverless applications. And if you don't quite grasp what serverless means, because there's everyone, that joke that's out there, how can it be serverless when it's running on a server? I'm right there beside you. I'm an old ops guy. I wanted to know the same thing for a long time, and it's all about the persona. A good example, and I think this is the next slide. Or it's actually the next one. So simplify developer experiences. That's the goal. We want developers to write code. We don't want them to have to understand infrastructure. It's not their job. It doesn't have to be their job. So that's the crux behind serverless. So it's serverless in that developers don't have to understand what server it's being deployed to. So the example, if I wanted to deploy something with Kubernetes, and I'm as big a Kubernetes fan as anyone, this is how I would deploy a simple hello web application. I would create a deployment object in Kubernetes. I would give it a name. I would tell Kubernetes how many replicas I wanted. I would give it labels so I could then find the application later using service discovery. I would tell it what container image to use. I would give it quotas and limits for the resources that it can consume. And then I'd have to define a service. That would be the thing I point, my egress, my load balancers at. That would then point back to the labels from my deployment object with all of the pods that get deployed. And well, I don't want my developers to have to know this. This is going to have to happen at some point, but I want the people deploying applications. I want those operations people to know this knowledge. I want them to have this knowledge. I don't want to have to thrust this into the developer workspace if I don't absolutely have to. So this is deploying something in Kubernetes, sort of a hello world application. This is doing the same thing with Cloud Run. This is what I'm talking about when I say I want the developer to do their job. It's a simple one-liner. Gcloud run deploy, hello service, and I feed in an image. And the tooling and the intelligence on the backside of the serverless infrastructure that's built on top of Knative, another open source project, does all of that for me. And I get a little bit of output and I get a URL to go to see my default app, to see my application running. That's an incredibly powerful tool. And I was a naysayer on the serverless front for a long time until I realized it wasn't for the ops team, it's for the developers. For the developers that just need to write some code and feed it into a system to get a URL out the other end to see what it's doing, this is an incredibly powerful tool. And it runs on top of Kubernetes. So all of the stuff from the background, this is all happening in the background. Deployments are being created, services are being created as needed. I'm not putting the onus of having that knowledge on the developer. And that's a really powerful thing. And that all gets built into Cloud Run on top of Anthos. Cloud Run on GKE, on Anthos, service on your own terms, and this is the marketing slide. Consistent developer experience, stateless services. Notice I said stateless. Serverless doesn't make a lot of sense if you have to store state on disk. Then you're getting back into a traditional Kubernetes deployment. But if it's a stateless web front end that's just feeding requests into some middleware layer or into a message queue, serverless can be a really good solution. All right, and then this is for lack of a better term, the call to action slide. This is the stuff that Anthos focuses on. This is what we want to be able to do. We want to have developers fulfilling mission. We want to have the operations teams getting good telemetry and good observability for their SLOs and their SLIs to make sure that the applications have the proper uptime and have the proper availability and durability. And we want to have the infrastructure teams deploying infrastructure in the right places to fulfill mission with the right cost level. And we're taking all of these millions of hours of Google engineering over the years since Google was invented in the 90s, since the first Borg deployment in 2003. And all of this is being brought to bear with what we're doing with Anthos.